Okay, so yesterday you had a lot of notes about exponential functions. Today it's going to be a little bit shorter. We're going to talk about exponential growth and decay. We're going to show like what the graph looks like, how to tell from the equation which is which. So let's start with number 1. We have y equals 3 times 1/2 to the x power, and we're going to write a table for it and we're going to graph it. So let's go to our calculator, go to y equals, put in 3 parentheses 1/2 and then caret x. Okay, so it should be 3 parentheses 1 divided by 2 caret x in your calculator. Alright, and then go to your table, press second graph, and I want you to find some negative numbers and some positive numbers so we can get a good look at what the curve looks like. So on your table, let's do when x is -2, -1, 0, 1, and 2. Okay. So on your table, when x is -2, your y should be 12, -1, 6, 0, 3, 1, 1.5, 2.75. So once you have your table filled out, we're going to go ahead and plot those points on our graph. Okay. So we have -2, 12, that's going to be off your graph. So let's go to the next one. -1, 6. 0, 3. 1, 1.5. 2.75. So you can kind of see that curve. It's going to get really, really close to this x-axis, but it's not actually going to touch it. Okay. So you have your horizontal asymptote at y equals 0 again. Okay, and you have this graph. Now this graph is decreasing. We go from left to right like we're reading a book. So if you look at this graph from left to right, it starts at the top and then it goes down, 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 and it's decreasing from left to right is what we say. Okay, and so it asks you at the bottom, or the next question on your notes, says what happens to the function y value as the value of x increases. Okay, so look at when your x increases, when it goes from left to right. What happens to your y value? And we said it decreases. Okay, but the way we say it, and you're going to be doing this a lot, especially in your other math classes like pre-cal, calculus, stuff like that. And this is what you need to write in the blank. As x approaches infinity, okay, that means as x gets bigger, then my y, or my f of x, gets smaller. It gets closer and closer to 0. So f of x approaches 0 is how we write it. Okay, and just to translate it, it says as x increases, y gets smaller, but it's not going to go past 0. So we don't want to say that it approaches negative infinity because it doesn't get past that 0. Okay, so we say as x approaches infinity, f of x approaches 0. Alright, and we're going to go to number 2. We're going to do the same thing. Put this equation in y equals, go to your table, fill in your table, plot your points on your graph, and then we're going to answer the next question. Okay, so go ahead and do that. We're going to keep the same x values, -2, -1, 0, 1, 2. Okay, so you should have a horizontal asymptote at 0 again. Okay, and then it's going to go up. This curve is going to be increasing from left to right. Okay, so and that question asked, what happens to the function y value as the value of x increases? Okay, so as x increases, we're going from the left side to the right side. So from left to right, my y value is getting bigger, okay? And it's gonna go up forever and ever. So here's what we say. We say, as x approaches infinity, positive infinity, okay? So that means as x is increasing, my y, my f of x, is gonna approach infinity also. Okay, as x approaches infinity, y approaches infinity. All right, so let's turn to the next page, or turn to the back. Okay, so on the back of that page, I'm going to talk to you about how to tell if it's exponential growth or exponential decay. So they give you an equation. It says in the exponential function, y equals c times a to the x power. Okay, what you want to do is look at your base. So that a, whatever your base is, if your a is less than 1, so if it's a fraction, if it's a decimal less than 1, your y, if you look at the front of your notes, when you had a base that was less than 1, what happened to that graph? Okay, and it was the very first one we did where it looked like this. We had a base of 1/2, I believe. It was 3 and then times 1/2 to the x power. Okay, when that happened, whenever you had a base of 1/2, my y was decreasing. Okay, so that's what goes in the blank. If a is less than 1, y decreases. Okay. And it's going to be a model of exponential decay. So if my y is decreasing, it's called exponential decay. Okay, so that means anytime you have a base, like the very first one we did, where we had a base that was less than 1, anytime you have that, it's going to be exponential decay. All right. Now, if a is greater than 1, like our second example, we had y is, what was it? 2 times 3/2 to the x power. You see how my base this time, if I were to put that as decimal, it would be 1.5. It'd be greater than 1. And I had a graph where the y was increasing, right? So if your base is greater than 1, your y increases. And this is called exponential growth. All right, so if my base is less than 1, it's exponential decay, and that curve is going to be going down. If my base is greater than 1, it's exponential growth, and my curve is going to be going up. It's going to increase. Okay, so on the next section, we're going to classify whether these equations are exponential growth and exponential decay. So all you're going to do is look at your base. That's it. You don't care about the number in front. You just care about the base that has the x as the exponent. So look at your base, and I want you to write down if it's exponential growth or exponential decay. Okay, I'm going to give you a few seconds to try it out, and then we'll check. Okay, so on part A, you should have gotten exponential growth. because the base is 5 is greater than 1. Part B, exponential decay, my base is 0.4, which is less than 1. C, exponential decay, my base is 0.25. And then the last one is exponential growth, because my base is 2.5. Okay, so you're going to do the worksheet. On the worksheet, whenever, like, it's going to have you figure out if it's growth or decay, just like what y'all did. It's going to have you match a graph to the equation. And it's also going to have you graph from an equation. And you'll see once you get it. But whenever you graph these, if you want to use the calculator, look at your table, go for it. Because these are a little bit harder to see, like how steep it is it shifted, is it stretched, stuff like that. So go ahead and use your calculator, look at the table and see some good points that you can plot. And yeah.